Yeah, thanks so much, Kyle, particularly on the karaoke. From solutions to standards, extracting data in Web3. That's me again, like the planets going around. I'm going to talk through three things. Firstly, just a bit of a welcome. That should be very short. We're going to talk about standards, and then we're going to talk about the new era of the graph. So firstly, welcome to Datapalooza. I think Kyle said it more eloquently than I would, but it's like to be here. I think the roster is absolutely stacked. I think there's going to be some really interesting stuff, but also some really interesting people to meet in and around the talks too, so excited to see everybody. But first, let's talk about standards. And when I say standards here, I don't mean having high standards, so obviously we want to have high standards. I'm talking about software standards. So a standard protocol, common format, can be used by software developers that provides a bit of certainty. And that sounds a bit dry, maybe, but I think standards are great. Standards often come about when you've got a common problem, when you've got people trying to solve the same problem. And what standards enable is people solve that problem in a standardized way. It means that people don't have to reinvent the wheel constantly. That's really great. It unlocks interoperability. And so interoperability means you can kind of integrate with things, but crucially, you can build on top of standards. So if you have standards, so if you start with the first internet standard, TCP, HTTP, you could argue that without these standards, you wouldn't have the information superhighway, you wouldn't have the flourishing internet that we know and love. Token standards within Ethereum, so ERC 721, ERC 20, ERC 1155. Some people might have different feelings about maybe the quality of some aspects of these standards, but it's undeniable that at this point, the flourishing Ethereum ecosystem wouldn't be quite the same if there wasn't this agreement on what a token is and what a token looks like. So really, I think when you look at any advanced technology, and there's so much of it around us right now, it's actually standards all the way down. It's the layers upon layers of agreed ways of doing things. And so standards are really powerful. And so obviously, sat there as a person being, oh, well, I think that sounds great, standards are great, I'll create a standard. This is a classic XKCD along these lines, where actually it's really hard to create standards just by defining them. So 14 competing standards, you need one to cover everyone's use cases, so then you have 15 competing standards. So I think that's actually an interesting thing about standards, that some things are born standards, so the standards I talked about before were defined as standards that people could build on. But some things become standards, and some things have standardsness thrust upon them. And so I want to talk about those latter two in a little bit more detail. Essentially, I think that what you often see in practice is that you don't have standards that evolve through agreement or consensus. What you actually have is people building a solution that over time becomes a standard. I think invariably, it's not just about building a solution and saying this is the perfect technical thing and then that becoming the standard. It needs to be open. It needs to be a solution to a real problem at scale. And then if enough people adopt it, it might become a standard. So we see this, again, in practice in lots of places. Git described as the worst version control tool that exists except for all the other ones. Postgres has become in many ways a single piece of open source software, but also a standard that others build their database platforms upon. They seek Postgres compatibility because that then unlocks a whole ecosystem. And you see the same thing in React, where React has become the de facto standard of front-end development in the Ethereum ecosystem. Within Ethereum itself, Ethereum always had a sort of standards-driven approach because client diversity was important from the get-go. But I think what's been interesting has been to see the EVM evolve as a common standard, which actually is adopted by roll-ups. They all seek to be compatible with the EVM. That's not necessarily because they think it's the best architecture, though obviously some people are really strong proponents, but also because if you are consistent with that standard, you get access to all of those other things that are built on top of it that are compatible with that standard. So that's been a really powerful driver of the Ethereum ecosystem, but then also the wider crypto ecosystem, Web3 at large. You see this above the blockchain as well, so you see this at the DApp layer. So Uniswap has defined what an AMM looks like, and there's been a proliferation of similar ones. I'm looking forward to hearing from Uniswap, talk from Uniswap later. OpenSea has also scaled, and by becoming the de facto NFT marketplace, it has essentially driven metadata standards and created a lot more consistency across different collections that wouldn't otherwise have existed. And then coming to the graph, so subgraphs, what we work on, which is the kernel that started the graph, subgraphs have become a standard for that layer on top of dApps. Essentially, as you go from blockchains to contracts to subgraphs, subgraphs sit on top of smart contracts, allowing developers to build in a consistent way, giving people consistency, and essentially gaining really wide adoption. Subgraphs have become a standard way for developers to build on top, and essentially take a lot of the complexity that is sat in this indexing layer, essentially this ELTQ pipeline, to package it up into a really lovely bundle that's easy to use, easy to get started with. And that has been the starting point of the graph. And that's unlocked a huge amount of the productivity and creativity that we see across Web3. So I think those first standards that we talked about, where it's defined and the standard sort of is fixed and everyone agrees to and builds around it, that's one class. But if you've come from this sort of solution space into becoming a standard, you solve the problem, you become a standard, what do you do then? So I think there are a few things that you can do. Firstly, as I said, standards allow interoperability sideways, but also layers on top. One of the things that's been really exciting over the last couple of years has been the Masari, so one of the core developers working on the graph, essentially taking on the Herculean task of standardizing all of the data in DeFi, building on top of subgraphs to create data standards, so whether you're interacting with the latest lending protocol or one of the OG lending protocols, you can get the same data, you can compare things like for like, apples to apples, and that's enabled by subgraphs. So again, that's building on top. The graph network is also built on subgraphs. This standard API used by many, many developers has created this flourishing decentralized ecosystem, many dApps being deployed, rolling out support for many more chains. And if you are a blockchain, please get in touch. There's a new chain integration process where we're trying to open up access to support indexing of more chains on the graph network. We're seeing great growth. So October on the graph network, we saw continued increase in query volume, more and more subgraphs, and more data consumers. However, developers are always beautifully, wonderfully dissatisfied. If you talk to a developer, once you've given them a new tool, they'll push it to its limits and then some. I think working on subgraphs, one of my most rewarding things is seeing the amazing and crazy things that people do with subgraphs, whether it's building an L2 in a subgraph to creating entire data pipelines that we never could have imagined when we think about building for dApps day to day. So you end up in the classic product conundrum of how much to expand your product, how much to expand your scope, going from not expanding it to enough, expanding it too much and losing focus. So with subgraphs, what we think about as our focus is making subgraphs the easiest way to build a powerful custom Web3 API. Essentially giving more people the reaction that I had in 2020 when I built on subgraphs for the first time. I actually wrote a blog post about it. This was before I worked at the graph, because it had transformed my development experience building on dApps. I had much less hair and one fewer children at that time. And so in terms of what that concretely means, there's a foundation of performance. Indexing blockchains has become more and more difficult. Essentially, you have more and more data to index. You've got increasing demands. So building on a foundation of performance has been a big focus for the graph node. So we've integrated the Firehose, substreams. We continue to do more and more pipelining and also fine-tuning of the essentially how data is indexed and processed so people get fast indexing, and that continues to be a focus going forwards. Developer experience sits on top of that, giving people that subgraph experience everyone has knows and loves, but continuing to think about how we can make things work better when it comes to local development, but also through to deploying to the network. And then we're increasingly working on adding new things on top. So off-chain data, so we've added more robust support for IPFS, and recently Arweave, file fetching, and we're going to continue pushing in that direction. Composition is something that we've been talking about for a while. There's a workshop with Simon later on composition at the client level with Graph Client, which I encourage people to go and see, but also more native graph node composition is something that we're thinking about. And that also unlocks multi-chain subgraphs, so indexing across chains is increasingly important for developers. And then finally, aggregations, so where subgraphs are super powerful in letting developers do anything, there are some things which we could make easier, like making time series. However, why don't we have both? So I've talked a bit about subgraphs. We've focused in on subgraphs, but I want to talk now a bit about the new era of the graph. So this was announced by the foundation last week, and essentially this lays out the roadmap for what all the core developers are working on across the ecosystem. So as Kyle said, Edge and Node were the first core developer, but it's been incredibly energizing and inspiring to see the new minds who've entered the ecosystem, who continue to push us forward, bring their expertise to the graph, and essentially this roadmap, and I thank ChatGPT for this, is trying to essentially show people below the surface of the iceberg to see a bit more of what's going on behind the scenes, and so people can get a sense of what's been worked on. So there are five pillars of the roadmap. I encourage people to go to thegraph.com/roadmap to dig it in a bit more detail. What I want to talk about briefly today is the world of data services. So firstly, that's a great name. But essentially, this is about addressing more data use cases for developers. I had that list of all the things that people want to do with data. And here, going back again to that conceit, to that idea of solutions turning into standards, we're taking two approaches. So on the one hand, we do want to build new solutions, but we also want to make sure that we're leveraging existing standards, that we're benefiting from a lot of the great open source software that is available in the ecosystem. So we're not reinventing the wheel. So on the first side, so in terms of creating new standards, I want to talk about unbundling the ETL queue. So extract, transform, load, query. As I said earlier, subgraphs encapsulate that into one deployable unit. Fires and substreams is a new technology, newish. It's been around for a while, but it's been increasingly scaled and tested at scale. It supports a lot of our indexing within GraphNode when it comes to firehose and increasingly substreams. But fires and substreams essentially takes the extract and transform stages. So the firehose has an incredibly high-performant way of extracting data from blockchains, putting it into flat files, which can then be really performantly streamed. So it's also changing the interface from the GraphQL polling interface to a streaming interface. Substreams, meanwhile, are again very focused on performance, but it's a parallelizable, composable transformation layer that can stream transformed, curated data into any manner of downstream syncs. So we're taking the subgraph end to end and taking these first two components. As I said, we're continuing to integrate these into GraphNode. But one thing I mentioned, composability, was that substreams are designed to be composable. So the idea is that where a subgraph has to currently be written by one author, substreams can compose multiple units from SushiSwap, from Uniswap, from Chainlink to create maybe a sense of average prices where different units, different substream modules have been written by different authors. They're really easy to pick off and combine, and that composability we think is going to be really important, particularly as data on-chain continues to become more and more varied and diverse. And this is all dependent on the firehose standard. When you have a firehose integration, you get substreams on top. And so the firehose standard essentially the preferred approach is that you update your client node so you can run it with firehose enabled, hyphen, and firehose enabled. And essentially, an integration requires three things: a method of data extraction, a data model for the chain, and then a Firehose implementation specific to that chain. And the team are really working on, the streaming fast team are really working on making this integration process easier and easier, and it's been really exciting to see not only core development teams build Firehoses, but also client teams themselves. And we've got some really exciting progress in essentially becoming more natively supported across the Ethereum ecosystem as well. But it's not just about building new things, and we do want to make sure that we're leveraging existing standards too. And that takes a few forms. So that could be SQL. So if you saw the different requirements, there's an incredibly vibrant ecosystem of data analysts and data scientists who work in SQL, who expect to be able to do ad hoc queries. And SQL is therefore an interface that we want to support. And there's a talk from Semiotic later on how the graph is addressing that. Similarly, LLMs have created this new sort of standard form factor, the prompt engineering interface, which again unlocks maybe a whole bunch of new use cases, and we've got some exciting developments in the graph ecosystem there as well. Files, so this is obviously super broad. Files can do lots and lots of things, but we also have some really focused use cases, which is what we think is important here, in that we have many, many indexes across the graph network. There's indexes that currently already engage in some sort of out-of-bound exchange of data. Maybe it's a precinct Firehose, maybe it's a precinct subgraph, and we want to essentially bring those kind of interactions, formalize those interactions a bit more, and so that's essentially the initial files use case, which could again expand. Then the ultralight client, and much more than I can go into in 20 minutes. And overall taking the approach that if we build things on top of open source, if we balance performance and verifiability, so I've talked quite a lot about performance, but verifiability, determinism is a really important aspect of what we build. And again, there's a spectrum of verifiability, and we're really excited to see some of the progress, for example, on verifiable substreams that's being pushed forward by Semiotic. But above all, keeping a focus on developer experience, making sure that we're building things that developers can use to power their applications. As we try and create more open source solutions, making sure we're solving real problems, making sure we're scaling, getting towards more standards. And that's what we're trying to do as we work together on the graph, at least as I see it. This is a nice animation, so I'll let it run. A lot of chains, a lot of apps, thegraph.com. And so what now? I'd encourage people to follow along, so thegraph.com/roadmap. We have core developer calls that people can join. We've got lots of open documentation, a lot of open discussions happening. Get involved, so thegraph.com/docs if you want to start building or thinking about building. Check out the forum. The foundation has grants for builders who want to build as a part of the ecosystem. Integration, so I mentioned the chain integration process, and new data services I think opens a really interesting avenue for new collaborations and integrations with people outside of the ecosystem. And finally, say hello to me or on Twitter. I'm not super active there, but I would love to receive more DMs, he says slightly nervously. But also please come and say hello to me in real life here. Really excited to see what the rest of the day holds, and thank you so much.